Mrs. Sargent, and this is lesson 5.1, dimensional analysis. Dimensional analysis is a math tool that is going to help us in solving problems during this unit. It's going to help us convert from one unit of measurement to another. This is used a lot of times in the pharmacy as well as in hospitals to calculate dosages for patients. So to start off with, what is a conversion factor? A conversion factor is a fraction where the measurement, the number in the unit on the top, is equal to the number in the unit on the bottom. So we have some conversion factors here. 1 meter equals 100 centimeters. So we can write this 1 meter over 100 centimeters, or we can write 100 centimeters over 1 meter. These are equal to each other. They would equal 1. We can write them either way depending on what we start with and what we want to find. 1 minute, there are 60 seconds. We can write 1 minute over 60 seconds. Or we can write 60 seconds over 1 minute. Gas cost $3.15 per gallon. Fortunately not right now, but if it did, we could write this $3.15 over 1 gallon. Or we could write 1 gallon over $3.15. And our label for our unit for 3.15 is that dollar sign. Or the density of lead is 11.4 grams per cubic centimeter. So we can write 11.4 grams over 1 cubic centimeter, or 1 cubic centimeter over 11.4 grams. It is very important that you label your numbers with the units. We do not want to have any naked numbers. This will help you keep track of, when you label them with the units, it will help you keep track of what you're starting with, what you're going to, what cancels out, and all of that. So what is dimensional analysis? Dimensional analysis is a way to analyze and solve problems using these conversion factors, the units of measurement that we are given. So we are always going to take what we're given and convert to what we want. Another way of looking at this is take the starting units, those given to you in your problem, and convert to the desired units, what you want to find. The starting units would cancel out, and we would be left with our desired units, what we want. So we have a problem here. How many centimeters are in 5.5 meters? What we are given, the only number and unit that we're given is 5.5 meters. We want to find how many centimeters. So 5.5 centimeters. Centimeters. And, 5.5 meters, sorry. Didn't mess it up. Got me off track there. 5.5 meters. So we have, if you remember from our conversion factors, we had these two ways of writing 100 centimeters in 1 meter. So we want whatever our starting units are here to be the units on the bottom over here. So since we have meters here, we're going to put meters on the bottom over here. And so that's going to have us have the 100 centimeters on the top. So our meters are going to cancel. So we're going to take 5.5 times 100. And so that's going to give us 550. And our unit is centimeters. And that is our final answer for this problem. However, sometimes the starting units cannot be converted completely to the desired units right away, so we have to use what we call linking units. So I can convert my starting units to some linking unit, and then I'm left with the linking unit, but I still don't want that, so I need to convert from my linking unit to that desired unit. And then I am left with desired units, what I want to find. So here's a problem. You don't have this in your notes, but it's a visual representation of what we are doing. We want to convert from 4 squares, and we want to find out how many stars is that equal. So we are given 4 squares, and we want to know how many stars is that going to be. So we're starting here with 4 squares. Well, our conversion factors are given to us here. We don't have something where we can go straight from squares to stars. The only conversion factor we have is going from squares to triangles. So we're going to have to use that to start with. So 1 square is equal to 1 triangle. So we've now gotten rid of our starting units because those are going to cancel. We have this linking unit. Well, triangles still can't go straight to stars, so we're gonna have to use 2 different linking units. The triangle here, 2 triangles is equal to 1 smiley face. So we're gonna put triangles on the bottom here, and we're gonna put our smiley faces on the top here. 2 triangles is equal to 1 smiley face. Well, our triangles are going to cancel, and we don't want smiley faces either, we want stars. But now we can go straight from smiley faces to stars. So 3 smiley face are equal to 2 stars. 3 smiley face, 2 stars. Smiley faces cancel. So now all you have to do is multiply everything on the top. So 4 times 1 times 1 times 2. Which would be 8, and divide by everything on the bottom. 1 times 2 times 3, which would be 6. So 6 stars, or 1.33 stars. So you actually see conversion factors all the time. Here's an example at the grocery store. So we have apples are $1.99 per pound, and we have a woman here, and her thought bubble says 2 pounds, and she's going, So the thought bubble, what does 2 pounds represent? How much the woman wants to buy. Wondering the cost. So the conversion factor is the $1.99 per 1 pound that's given to us there. So we're going to use dimensional analysis to find the cost of 2 pounds of apples. So we're given 2 pounds of apples. We want to know what is the cost. So we're going to start with the number and the unit that is given to us. And I normally draw these as train tracks. It's the same thing as multiplying the fractions together. So we have 2 pounds of apples. We have pounds up here, so we need pounds on the bottom down here. So 1 pound, $1.99 per pound. So I just want to show you that you can write this in 2 different ways, and it is going to give you the exact same thing. I prefer the train tracks method. If you would like to draw them as fractions, that is perfectly fine. So our pounds are going to cancel. So we're just going to take 2 times $1.99, and that's going to give us $3.98 as our total cost. And The only unit we're left with is that dollar sign. We don't have any other unit left because that is the cost. It doesn't ask for cost per pound, it just asks for the cost. So some other examples using dimensional analysis. How many seconds do you spend in school in one day if a school day is 7 hours long? So what we are given in our problem is 1 day. This is what we're given. We want to know how many seconds. This is our conversion factor here. So we want to know seconds. And I typically underline what I'm given, circle what I want to find when I'm drawing these. So I'm going to start with 1 day. And we don't have something going from, or we do, day to hours. So school day is 7 hours. So since I have days up here, I'm going to put days on the bottom, 7 hours. But we still don't know how many seconds. Well, we know a linking unit would be in 1 hour. We have 60 minutes. But that's still not seconds. So in 1 minute, we have 60 seconds. And that's going to give us the units that we want. So then we just have to multiply across the top and divide by everything on the bottom. Here it's 1, so it's just going to be itself. So this is 25,200 seconds is how long you spend in school in a 7-hour day. Our next problem, a football field is 100 yards long. How many centimeters long is it? So we are given 100 yards. We want to know how many centimeters. And we have some conversion factors here that are going to help us with this problem. So we're given 100 yards. We want to know how many centimeters. So we're going to start with what we're given, the 100 yards. Then I can convert from yards to feet. So I'm going to put yards on the bottom. So 1 yard goes here. 3 feet is going to go on top. That's going to cancel out the yards. Well, I don't want feet, I want centimeters. So I'm going to convert from feet to meters, my second linking unit. So 3.28 feet, 1 meter here. Feet are going to cancel out. I don't want meters, so I'm going to go 1 more. In 1 meter, we know that there is 100 centimeters. So again, I put meter on the bottom because I have meter on the top here. So that leaves me with centimeters. So we're going to take 100 times 3 times 1 times 100 and then divide it by 3.28, and that is going to give us 9,146 centimeters. You have some practice on the next page, just some simple dimensional analysis to get you used to using the math, so that will prepare us for this unit. Thanks for stopping by. Have a great day.